So we're gonna have our fireside chat session. We're gonna have Percy come up. He's our lovely instructor for this class, and let me change this to this window. So all of you have submitted a lot of interesting questions, and we'll try to hit as much of them as possible. But there is a schedule, and there's no guarantee on what questions we will ask. But please, there will be live Q&A sessions, and you can raise your hand and shout, and I will signal when that is. Try not to, to be too eager on asking your questions. So the way this will run is that we have 3 sections. We have career, life, and research advice. We have class, Stanford, and miscellaneous questions. And then we'll have a section on AI and its outlooks. Okay? And then we'll go through them kind of one by one. And then it'll be more like a guided interview per se.
Okay.
Sounds good?
I mean, we can also go off script if needed.
Okay, so we're doing something different. This is a fireside chat. This is Percy. Percy, this is a very good way to get the, a personal perspective to, Percy and ask questions. We'll start with the background introductions. So what's your first AI class when you were undergrad? What did you take? What did you learn? Is it similar to 221? Is it not?
Yeah. Oh, you're asking me to remember something from quite a while ago. So I did my undergrad at MIT. So I did take the undergrad AI class there. I remember it, I don't remember it being, at that time I was much more interested in theory and algorithms. So it wasn't like I took that class and I was like, okay, I'm going to be an AI researcher per se. I think part of what I remember is that back then machine learning wasn't as kind of pervasive or important as it is now. And so a lot of the more, classical AI techniques, I could see kind of limitations in how they could scale. So I remember taking a class on NLP and doing grammars, and we were just writing grammars by hand, which didn't feel very satisfying. It wasn't until later during my undergrad when I did algorithms and then got into machine learning and statistical language processing, this was early 2000s. This is when it first started kind of really taking off. Then I found this is the way to combine really kind of interesting math with kind of more scalable algorithmic approach.
Mm-hmm. So you mentioned that there were techniques like grammar and some old techniques that didn't work as much. Was there a turning point where you were you look at these techniques, they don't work that well, you could have switched to do something else? And why did you stick with AI back then?
So, I got into AI when I was already doing machine learning. In fact, the first project I did back in 2005 was essentially what you could call training a language model. That back then, of course, it wasn't a transformer. It was a hidden Markov model. And there was a particular way you train it. But the idea was the same. You would take a large amount of text. Back then it was, I think maybe 100 million words, instead of, trillions of words. And then you would, maximum likelihood. It's the same thing we do now, but with a different architecture and a different learning algorithm. And at the end of the day, you get this model which had features. It would basically cluster the words. And I remember seeing how it would automatically figure out, here's a cluster of city names, or here's a cluster of days of the week, and so on. And that was a moment when I thought, wow, this is really, I guess you could call it emergent capabilities. And that's why I decided to go pursue AI.
That's a very interesting journey. 10 years later, or even 20 years later, now the world is very, very different. Did you expect any of this to happen, like language models to dominate the AI paradigm? Or, were you back then still thinking about other kinds of techniques? And
so it's interesting because even 20 years ago, there's this idea that training generative models on large amounts of data can be useful. But I don't think I think anyone had the imagination to think that if you just kind of certainly, well, I'll just speak for myself, but I think most people did not as well have the imagination to think that if you just really stuck with that idea and carried it to its logical conclusion, that you would get, GPT-3 and GPT-5 and things like that. I think that the transition towards interesting word clusters to like zero-shotting a bunch of different tasks, that was a pretty major leap that, even I think if you talk to the OpenAI researchers, I think there was a conviction that this was the path, but whether it would come in 2020 versus 2030 or 2050, I think no one knew.
Now is a good time to transition into AI outlook. We can ask about what we think about AI happening now, what's going to happen in 5 to 10 years, and we'll get Percy's thoughts on that. So, what's like one concrete thing that changed about all of this in your mind when you think about AI systems in the last 3 years, seeing all this happen? Like maybe before you were thinking more perhaps in terms of like principles and techniques and algorithms, but right now it's just data and compute. Is there anything else that really drastically changed your thinking, seeing this progress?
Well, I think the big shift, I think if you think about AI, is that before it was very much a researcher thing, right? AI researchers, they do a bunch of experiments, they write papers, and now you walk on the street and everyone's talking about AI. You drive on the 101, there's like AI billboards, and it's become not really about a research thing, but this is about a kind of a global phenomenon. I mean, this happens, like it happened with the internet, for example, as well. I'm probably, not many people were around when that was happening, but so that's a big shift. So I think a lot of the conversations have broadened, instead of thinking about just the techniques and the principles, but think about Rishi's lecture from last time. You think about data and energy and compute and resources, and think about jobs and all these other things, because AI has kind of escaped the lab in some sense and is actually having real impact in the world in a very substantial way, right? When you have the entire national policies being written about AI, or you have an AI first strategy, or companies calling them, like the biggest companies call themselves AI companies. I mean, this is like a pretty big, shift. Mm-hmm. I think it's important to remember that the research still continues, right? Mm-hmm. My group, many people at Stanford, other universities, folks in industry, there's still a lot of open problems, and things that we don't understand and things that could be a lot better. But that's always been the case and always will be the case. It just happens that there's sort of this off-ramp, if you will, from the research highway, where it's like, oh, okay, now we can actually get a bunch of kind of impact here and now, as opposed to always thinking about the future.
Mm-hmm. You mentioned a lot of things there about like the role of like research and then the public perception, having billboards on 101. Let's start with the public perception, because we're talking about how AI is happening today. What's something that you think is very correct and very incorrect about the public perception of AI today? When people think about AI, what's something that you want to tell them that, is the wrong way to think about it, or this is the right way to think about it?
I think a lot of AI perception, unfortunately, has been kind of shaped by, science fiction, the Terminator and all those. Actually, it's interesting because in the US also, it's very cultural. Like the way that people think about AI is very different in the East than in the West. I think there's much more of a kind of a dark, bleak outlook here than, whereas in Asia, I think it's much more of an optimistic, this is a technology that can really transform. So that's a kind of a first thing that's interesting. I personally think that there's a lot of like baggage associated with kind of, science fiction. And I think things could be either better or worse, but in very different directions than what people typically think when they're anchored to, the idea of a sentient agent that comes and either, destroys. I think that the way I think about it is that AI is already everywhere, right? It's making decisions much in the background. So think about it more as, infrastructure, right? Like, or what recommendations you get on your phone. Now, I think with, ChatGPT, it's more kind of user facing, but I think the way that AI will influence our lives is much more pervasive, and much of it might be hidden, compared to, some AI walks through the door, right? That's really good for movies, because it's hard to have like, I don't know, some abstract thing kind of walks through the door.
AI working on your spreadsheet, that doesn't.
Yeah, that doesn't seem very, Hollywood.
On that note, what's the most overhyped capability and underhyped capability of current AIs?
Well, I think I'll start with the underhyped one. And this is specific to language models, right? I think language models, if you think about for much of their existence, they're probabilistic distributions over an X token given the previous token, right? So they're mathematical objects and you can study them as such. And now they've transformed into essentially more like a system that you give in an input and you get an output. So one of the things that I think is underappreciated is that how much that kind of probabilistic view and how much like minimizing perplexity and having strong foundations, it really enables all of this, right? There's a lot of, people think about it as pre-training and post-training. So Ken's lecture, I think, gave a good overview of that. And a lot of the visible things come from post-training. Like you teach the model how to solve math problems or do coding or give, analyze financial documents or what have you. But I think it's maybe obviously hidden that many of the things that make AI tick is the ability to predict the next token. And one way you can see this is if you look at the ability for AI language models to predict the next token as a function of sequence length. Like a good system or a good model should really be able to kind of deeply understand the context and lower your loss as you predict the next token, even to let's say 1 million tokens. And measuring that loss is something that really gets at the true underlying intelligence or capability of a system, which doesn't really, I think, show up, I think, when you look at these public leaderboards.
That makes sense.
Maybe an overhyped thing is, obviously a lot of people are interested in thinking models and reasoning. Honestly, if you look at least when I look at some of these thinking traces, it just seems like it's a very long sequence of very rambly, a lot of inefficiency there. And yes, you get eventually to the right answer and you get good scores. But it's like, man, this must be a scam to get you to generate more tokens. Right? That's what it feels like.
In fact, even today, we can't even be sure that the thinking, we don't even understand how the thinking trace precisely helps the model. Is it just more budget or is it just actually guiding the thinking? Sometimes the thinking trace can be just wrong, but still get you to the right answer. Okay, now let's look forward a little bit. You mentioned that there's still a lot of research to do. Some people will agree with that. Some people will not agree with that. In particular, some students may think that, the role of academia is diminishing. Like there's just not too much, work to be done at school because we don't have the resources. We don't have to compute. What do you have, what are your thoughts on that? And, is AI already solved really? We have the bulk of it already?
Yeah.
Or are there really more breakthroughs needed?
Yeah. So I guess this is where being a bit older helps. You can see over the last, 20 years, I think academia has always been a very small fraction of what's happening in the world, right? We're always like this kind of forward-thinking, weird group of people who do weird things. And if you look, let's say, even 10 years ago, or maybe let's say 20 years ago, and if you were to go at Google and say I have this really great machine learning algorithm and we should use it in search, they'll show you to the exit because that it was sort of understood that, well, these things aren't reliable. They don't work. And so research has always been in this position where, it's like barely working, right? That's the definition. And what has happened over the last 5 years is all this very methods that people are working on with scale, of course, and data and compute start working. And now there's a sort of, now if you go to Google, of course, they'll welcome you in. It's like, oh, work on Gemini. There's a sort of, we're at a sort of transition period. And it's not that academia is being less relevant, but more that the techniques were suddenly becoming more relevant. Like there's a sense in which like many of the techniques graduated from school, I guess. That's kind of apt. But there's always more things, like some of the fundamental questions about how you can really generalize well, and how do you become more data efficient, and all these things are not solved by kind of any means, but that doesn't stop you, and it shouldn't stop people from trying to productionize the current best. So one class of things that academia is still really should be doing, I think, and can be doing, is kind of much more longer term kind of blue sky research. I think some of the feeling that you might get when you talk to peers is that, they don't see where that is, because I think part of the thing is that the thing that everyone has looking at, which is these particular transformer models, if you follow them, well, they're graduating to industry. But if you're looking over there, of course, you're not looking at the new opportunities. The other class of things I think is that there are a whole class of problems that academia is very well incentivized to do, but industry is just not. For example, we've been doing a bunch of work on understanding, copyright. How much memorized content can you get out of language models, right? So clearly, labs are not going to go do this sort of work because they're already getting, sued. And so if any academia, since we have no skin in the game here, is the only ones that can actually do this work. Or if you think about evaluation, how do you evaluate models in a fair way or expose problems with these with these models? This is something, again, which is harder to do in certain contexts in industry because there's a conflict of interest. Like you have to always be pushing the capabilities and showing that your model is great rather than finding necessarily flaws with it.
Yeah, it's very interesting. On the role of academia, there's both research and education. So you touch on a lot of research problems that are not yet solved. But on education side, a lot of us are CS students. We have a lot of undergrads here. And one of the things that students commonly worry about is that I'm going to graduate and go into the software engineering market. But today, the AIs are already very, very good software engineers. They can implement a lot of things much faster than the average graduate.
Yeah.
What do you think about that, and what the role is of the university to prepare them into this market?
Yeah. So Rishi showed a nice slide from last lecture, which is, it is true that the number of entry-level software engineers, as it's currently defined by the skill set that has been traditionally the case for the last 10 years, is going down. So you can't expect to just do business as usual, learn the same, take the same CS classes, assuming that they aren't changing, and just get a job. I think that this is very much a transition period where, I as an instructor and others in the department are really trying to figure out what education and the workplace should look like. And it's a sort of a joint problem. I think at a general level, I'm not, concerned that, people won't have jobs. I think that, the types of things you might have to do will necessarily change. If you look at previous generation of technologies, like, from being able to do, before if you could do, mechanical computation really quickly, that earned you a job, right? And then calculators came out and they're like, okay, you can't get a job by just like multiplying numbers all day long. But that doesn't mean that there aren't other things to do. And in fact, I think once you get the primitives where, I just have to, specify what I want and the AI will just write it, frees up opportunities to build other things, right? In the limit, if you think about, think about the CEO of a kind of a company, right? He's probably the busiest person. It's not that, and there are people kind of underneath who have many more, at least technical and maybe other depth, in terms of depth, have way more skills, but there's still sort of a job, and not just the CEO, but probably the whole management chain of essentially directing and also deciding what needs to be done. So I think, long story short, there's a shift more towards from doing to actually figuring out what to even do in the first place. And that is actually really, maybe that's one kind of takeaway, is that, figuring out what needs to be built. Like, suppose you had a tool that could build any app in 5 minutes. Like, what would you build? Right? And thinking about that question, which is that's not a trivial question. Like, what app would actually take off or be useful to people? That's a very deep question. So focusing on those problems, like the people who can do that well, are people probably going to be able to survive in this new environment.
So you mentioned finding what to build is a very important question. So from your perspective, in the next 5 to 10 years, or even next 3 years, what are the application areas that you think are undervalued, that students should think more about building in? They have the skill set of the CS education, but what should they do? What's undervalued right now?
Yeah. One perspective is that a lot of AI is almost synonymous with these frontier models, which are essentially everyone gets exposure to AI systems like Gemini or ChatGPT. But I think if you think about the underlying technology, the idea of training a foundation model on tons of data and unlocking new capabilities, this is an incredibly general purpose technology, right? And you've seen it successfully applied to DNA sequences. And if you think about the amount of other data out there, whether it be climate data or time series or kind of other satellite imagery, there's many other data sources where the same type of intuition should be able to carry over. And I think there's a lot of I think just scratching the surface of this technology that can unlock a lot. So I encourage people to think outside. Here's yet another an AI assistant, and think more about all the other areas outside CS in other disciplines, in the sciences, physical, materials, neuroscience, and think about where there are opportunities to apply the same techniques.
All right. We now have a slot for live questions. If anyone want to ask a question. So the question is, what is your projected impact of AI? Is it just a tool, or is it going to be drastically transform society?
Yeah. So if you look at Rishi's slide from last time, is it the technology of the year, the technology of the decade or the century, or or ever? I would say, century would be kind of my guess. I do think that this is a pretty, the general purpose nature is pretty, powerful in a way. I guess century, well, I think about computing as the other thing. Computing was a huge deal. And that was 70 years ago. So this is probably a kind of a similar magnitude of unlock.
Do current frontier LLMs pass the Turing test? If so, what's the next goal? Has AI been solved, or only scaling and incremental improvements?
Yeah. So, I guess the first thing to address is whether the Turing test is the right way to measure it and how it's defined. In terms of, I think on the first day of lecture, I mentioned the Turing test, and I think it's historically been kind of important in many ways to shape the development. I think right now, I don't think it's like a good measure of what it means, what progress means, both the imitation part and also humans being the benchmark. I think that AI we want AI to be kind of way better than humans at certain things. It should be much more reliable, for example. So putting humans at a bar doesn't seem particularly, it seems like a bit short-sighted, I think.
Would there be a easy to understand test, like a new Turing test that you have in mind?
I think in some sense, often tests are static, which means that you have to, you have a system, it enters a room, and then you get a score out. But I think that obviously has kind of problems because they're gameable and so on. I think a better metric is just kind of in an online sense. So the way I think I would propose is, how many new scientific discoveries is AI, producing? And that is not gameable, right? Because if AI cures cancer or does some, invents some kind of new light material or figures out, fusion or something, that's going to be, there's no one can disagree of like, oh, okay, that was cheating. Because if you cheated somehow and you figured out how to cure cancer, well, good for you.
Good for you.
Yeah.
All right. We'll now switch gear to talk about Stanford and classes and CS221 in particular. So we'll start with the class that you're all in right now. So, when CS221 started 10 years ago almost, and, this year we're thinking about how to make it better. We're trying to design it better. So when you designed it, trying to make it better, what were you thinking? What problems were you trying to solve to make this class better as an introduction to AI class?
Yeah. So there's a few years along the way where we've made large changes to the class, and this was one of them. And there were multiple objectives here, and in hindsight, it was probably a bit ambitious in terms of how much we wanted to do. But first, thinking more about the social impacts of AI, that has always been, as I mentioned a few minutes ago, hard to kind of incorporate, because from the ground up, when I designed this class from scratch, like 11 years ago, it was a technical class. We didn't worry about or think about the societal impacts as much. And so the whole structure of how the class is built doesn't really naturally incorporate that in. But at the same time, it's clear that an intro to AI class needs to confront some of these issues. So one of the things we did is in the latter part of the class, have dedicated a homework and some lectures to that. Obviously this is kind of work in progress and we can continue making it better. And if you have feedback, I'd love to hear it. The other major thing we did was I've always found it the disconnect between kind of lectures where you're looking at abstract diagrams and there's sort of like you look at something, you think you get it, and then you go to the homework and you try to code it up and you realize, wait, actually I don't understand how this connects. And one of the things that was successful when I taught the 336 class, language models from scratch, is to use this executable lecture format where we walk through code, so there's no ambiguity about what objects we're talking about. And so this year has been a bit of a pilot in terms of bringing that format to this class. Now, obviously there are, for the first time something happens, there's always kind of some rough edges. So I appreciate everyone's patience with that. I do strongly believe that, iterating on this, will produce just a much better, experience, which, combines the both of being able to have intuitive, concepts, but also grounded in the code. So, you can kind of see the whole stack.
So 11 years ago, when this class was designed, to some extent, we didn't have quote unquote working AI. So AI is like a concept. It seems to be applied in narrow domains. But right now, every one of you have this ChatGPT, this UI thing, this cursor that are actually working. And we spend a lot of time on things like search, MDPs, graphical models, and logic. And none of that seemed to be connected to this abstract AI product that everyone's using today. How should students mentally connect these pieces to this large language models paradigm that we're in right now?
Yeah. I think hopefully I've tried to convey that many of these concepts are actually quite relevant. So in search, for example, we think about states and we think about actions and exploring different possibilities. This is exactly what kind of test time compute with language models is about. It turns out that you can't just train a model and then be done. There's an inference time problem of, given a model, how do you search over different kind of solutions? And if you think about solving really, really hard problems, like I guess an IMO problem, or just doing some sort of scientific discovery, or writing doing some data science problem, it's going to require trial and error, right? And that's search. And Markov decision processes, MDPs, which is, it's very much like in language models, when you pre-train a language model and then you do reinforcement learning, that's basically trying to, learn a policy that can give you good, results. So that's, clearly, related. Any other ones I should defend?
Well, that cover a lot of them. But the other part that we want to cover is more on a more meta level. CS221 is a introduction to AI class, but AI is here, and AI is very productive. What should such an introduction to AI class really prepare students for, apart from just the concepts and knowledge? Is there anything else such a class should do for students?
Yeah. I've always been a strong believer that you should understand the fundamentals of how things are built, and kind of peeling over the layers until you get to the bottom. I think there's many things you can do if, let's say, you just want to get a job, right? There's many online resources and tutorials. You can basically learn how to do ML engineering or whatever you want, and be just fine. But in some sense, the whole idea of having why you're at Stanford and having a kind of a general education is the sort of a longer term thinking of both the breadth of topics, like things that you would just never encounter in the short term if you're in a kind of a job, on the job, learning on the job. But also thinking about kind of a layer above the kind of, okay, I need to get this PyTorch program kind of working. And so 221 tries to lay out, some of those abstract ideas and also ground them into code.
We'll now ask some very quick questions on classes. These are very common ones. How would you compare 221 to other intro to AI classes such as 229? Is 221 enough to get students to the next level of classes such as 36 or 224N?
Yeah. I think by now, a lot of these classes, so the short answer is yes. After you take 221, certainly you can take 229 and 224N. In fact, a lot of people also take them in different orders, because some of the topics are sort of orthogonal. I think that, as for 336, this is probably a kind of a different level of a class where it does require a bit more kind of, not so much knowledge, but just experience, and, I guess some amount of grit to go through, building all of the whole language modeling, stack from scratch. But certainly this provides a good foundation.
So the question is, what's your approach to research, and how do you come up with topics?
Yeah. Figuring out how to do research. It's definitely not an easy thing. And certainly I wouldn't say that I automatically know what research topics are going to. It's like kind of betting on the future, right? And you can only, to try your best. The way I think about it is research is about taking bets. So I think zooming out and looking at the world and seeing, okay, what is like a big hole that doesn't, that needs to be filled right now, right? I think the best research are ones where there is some sort of vision on what you're trying to do, and at the same time, there's a concrete first step you can take. So, I mean, just one example. This is, just the first thing that comes to mind is a few years ago, I was thinking about like decentralized training. So the idea was that instead of having current language model training, which is all the compute has to be in one place. Imagine if everyone in this room and everyone in the world could plug in their own compute, and you could have this peer-to-peer network, and could you train a large foundation model? So this is obviously would very much change the kind of the power dynamics and what it means to even train a model, and has implications like AI policy and all of these things. And I think of that as like it's an interesting research direction. And now you can work on the kind of first technical problem, which is more of a kind of a systems problem. And so there's, I guess the other perspective, and this is more about research taste, is that I often try to think about research problems where I generally don't know the answer, right? And this is like if I basically, like things that are the boundary of like what could work and what could not work. Because part of research is about information gain. It's not about necessarily, I can do this really quick thing and I can get a 5% improvement, because, that's in, let's say 10 years, no one will care about that unless there's some sort of more generalizable lesson you can take away.
Mm-hmm. Any other questions on Stanford classes 221? And take one from the list. So there's some questions about advice in the CS PhD, which we'll get to in the next section, career life and research advice. We hit this one already. Okay, this is an easy one. How do we increase the chance of becoming a 221 CA?
At this point,
perhaps next cycle, unfortunately.
Well, I mean, yeah, doing well in the class and being proactive, I think, is something that we like.
Or
be like these people in the front.
Or be Percy's PhD student. You get signed up. You don't apply. Okay, so let's switch here to the next section about career, life, and research advice. So here, I think this is where we get the most questions. Let's just start with something simple. Like today, what would your first job be if you were undergrad here at Stanford? You take these classes, you learn how to do CS, implementations and a little bit of research, about all this. What would your job be?
What would I want it to be, or
what would you do?
So I graduated from Stanford.
Yes,
class of
25.
Six. Yeah, and then I go and
apply for jobs.
Kind of a strange question. I mean, I think, okay, so what are the options, right? Mm-hmm. You can go to kind of a big research lab and build, the next generation of AI. I think you can do a startup, or you can go to grad school. Mm-hmm. I guess you could go to law school or business school or these things, but that's not a job, I guess. I think that, I guess this is going to sound a bit cliched, but I do think that there's a lot of interesting, okay, so backing up, I think, when I graduated, I had zero interest in startups. Maybe that's because I graduated from MIT or something. And recently I have been more engaged in the startup ecosystem. And I do think that there is something kind of really cool about a small set of people working closely together on some, problem. So, I mean, it doesn't have to be a startup, but I think the idea of kind of being very mission driven and trying to work on something that requires a bit more than just kind of an individual level contribution seems most kind of interesting. Mm-hmm. And then I think I'm a researcher, so I think, being able to work on interesting research problems would be something I would want to do.
Mm. For many students here, I think students are facing this choice between, research, industry, startups, all the things that you mentioned, but, they wouldn't know what to choose. It all feels very, very exciting. It all feels lots of possibility there.
Yeah.
Like, what would you do? Like, what's your, value function there? Or what would your rule of thumb be?
Yeah, I mean, probably I'll try to answer the question I think people want to answer, which is less about what I would do, but it would be like, what's a framework to think about things? I think when you're graduating, right, this is your first job. It's most definitely or most likely will not be your last job. So you're not like getting married or something. It's like something that is probably you're going to spend a few years there. So the thing I would prioritize most is growth, right? I think, you graduate here, you learn things at Stanford, but the next part of your journey is still education. It's learning. It's just a different type of learning. So I would heavily prioritize, I guess, maybe the more, to use an LRL analogy, exploration rather than exploitation part. So based on that, what would you do? Like being like with good people who you enjoy working with, I think is the most important thing. I think everything else is, I think, actually, secondary in some sense. It could be in an academic setting, it could be in a startup setting, it could be in a, group, but, in a larger company, as long as you feel like you are learning what you want to learn. Mm. Now, of course, I think if you have a mission, like you want to go, invent and, solve the world's energy problems, or like you have a mission, then I think it's actually much clearer, right? But I think that question probably comes from a point where, well, there's a lot of interesting things I could do. What do I do? And then I think using like where would you learn the most would be my top choice.
That makes a lot of sense. Commonly, students would also feel that, if they are not doing this or this by, sophomore year, they're not doing XYZ by their junior year, they feel that they're lagging behind. It's almost like a competition. It's almost like I have to, try this or else I'm too late. Do you have any advice to that kind of like mindset or feeling?
Yeah, I mean, I get it, how there's a lot of, pressures, and you look at people around you and they're doing all of these, crazy things. I think to put things in perspective though, if you look at top researchers at labs or people who are like or CEOs or people doing very well, you realize that, many of them took a very circuitous path. And maybe they went to a different field altogether and then transitioned. Like how many people have transitioned into AI, and they were doing something completely unrelated. So I don't think that what internship you get in sophomore year is really going to have any sort of meaningful, impact. I think it's still about kind of you and what your skills are and what you learn and your outlook on the world. Mm. That is the most important thing. And I think any of these kind of honors, so to speak, like it becomes very clear, I think, when it's just like, oh, this person has just racked up a bunch of like, good sounding names, but actually isn't as qualified as someone who maybe hasn't done as much, but, they're actually, skill-wise better positioned to succeed.
I have two follow-ups to that. One follow-up is you mentioned skills and like knowledge and applying them, but the world is changing so fast right now. There's so many like the things that AI couldn't do 6 months ago that they now can do. As junior students, you would worry that your skills would be outdated. So what would you say to that? And second is from your perspective, how do you then evaluate skills? You're saying that maybe some person had this shiny CV, but that might not be a better person compared to someone who hasn't done all these things.
Yeah. Okay. So maybe the first part. So one skill that will never go away is the ability to learn and adapt, right? I mean, that just almost by definition, right? In a fast changing world, the only thing that matters is how fast you can quickly adapt. Like if the model can do your job, okay, how can you learn something new? Which is why I emphasize so much, like, can you learn? Not just learn deeply, but also, quickly. Because that will be the most kind of important thing, I think, in a fast moving world. And then there's a second part.
Same as how do you evaluate skills and learning?
So basically, how do you interview people in such? Yeah, that is a tough problem. I think there is, there are some, like, obviously there's the usual tech screens and, getting a sense of how you can do work trials to evaluate how people work together. I think there's a bunch of other, softer skills. For example, there's a sense of which, having, grit and passion and those type of things really do kind of matter. Because the difference between someone who like really is into something and cares and someone who's just like kind of doing a job is pretty night and day. Also, working, again, this is, kind of cliche, but like working well with others, collaboration is something that, actually, it's just like very so important in any sort of context. And this is something that I think, we don't train students that well, I think, at least not explicitly, because most work is individual and evaluation is supposed to be individual. And sure, there's some group projects, but those are not really, I think, the main, focus. So, but in the real world, everything is collaborative and you have to be able to interact with other people.
That makes sense. What's a common piece of advice that you hear for a career that you actually don't agree with? That people say, you should do this, you should do that, but you don't think that's true.
I don't get very much advice these days. Maybe along the lines of like, advice, you have to go apply to this internship, otherwise you'll be left behind or something. I think that maybe it's just kind of the same answer as before.
I see. So, AI is very, very hot right now. Is there a bubble? And does the bubble, if there is, does the bubble distort student choices? And do you have any thoughts on that?
Surely there's a bubble.
There is a bubble.
That's like you would think there's not a bubble. And certainly that just, it distorts not just student choices, but it distorts like everything in the world.
Everything.
Right? Like if you look at the investments that are made in like big companies and decisions that governments take, it's just like very much shaping how the entire world is operating. I don't think, I wouldn't say that it's necessarily all kind of bad, because I do think that AI is real. Like if you think about the internet revolution, right? That's, I think, a prime example where there's clearly a bubble and we know what happened in, 1999, 2000. And yet internet is like completely transformative. Like it's like just very much changed the way that we've do things. Every aspect of our lives is now kind of, digital. Well, okay, maybe not every aspect, but many aspects are most aspects are digital in some way. But, obviously I think there's a period where you just overpromise and you underdeliver, and then you kind of recover. So I do think that, AI, there's a lot of like real things there, and there's a lot of things that are, kind of bubbly. Mm-hmm. And at some point that stuff will get cut out, and then the real stuff will, continue.
Makes sense. The question is, what are you studying in undergrad? How did you decide to do it? Why does it lead to where you are now?
This is going to be a pretty boring answer. So I studied computer science in undergrad. I did also, I did a math major as well, but it was really, you had a lot of overlap between, CS, because I was doing a lot of theory and math. And then I did a PhD in computer science when I got into kind of, research. And now I'm a CS professor. So I guess that's kind of a boring answer. I mean, I think there were, maybe periods where I was, I was really kind of fascinated by physics at some point, but didn't really, maybe I didn't really pursue it as much because, I was kind of, I don't know, it just felt very comfortable to be able to build things in software.
So the question is about why are these companies also non-transparent? What are the outlook around that?
Yeah. So the amount of transparency over the last 5 years has really gone down. It used to be that OpenAI would publish on what they're working on, release models, and now there's no information. I think that, so to answer the question directly, why does this happen? It happens for a few reasons. One is that competitive advantage, right? This is a usual reason companies have trade secrets. If I reveal how I did this training, then my competitors are going to, find out. The second is, lawsuits. If companies are, obviously training on a lot of internet data with some of it might be kind of dubious. And if this is all kind of laid out, then that's just kind of inviting lawsuits. And the third is a more mundane answer, is that some things that companies would probably be fine with revealing, but it's not a priority, right? It takes actually a fair amount of engineering effort to dig up certain types of information and put in a report and get it past approval. And all these companies are just kind of, their first priority is to race to build the best AI. So no one has time to do that, which is unfortunate. So the idea behind the transparency index was that at least you call this out and you make it people aware of it. And that's the first step to at least stimulating some more transparency. And over the last 2 years, there have been companies that have moved quite a bit. And we've engaged with a number of companies and they've done their best. But some areas like data are just, there's no incentive. It has to be kind of regulatory to really get them to move.
The question is, how do we get end users to care more about the ethical implications of AI?
Yeah, that's a really great question. Well, I think the first point is maybe related to the transparency, is that end users generally don't even maybe think about where their AI, how it's made, and so on. So just being transparent about that allows them to actually point to something. I guess there's an analog between how do you get consumers to care about like ethically grown, sustainable food and all these organic food and so on. It's kind of a very similar analog. And so having nutrition labels and like, I think it takes advocacy on behalf of other organizations to push for certain things to be in place so that they can be put in front of users, because users most of the time are just trying to get their, work done or do whatever they, and aren't really thinking about like, oh, is this ethical or not? Or many people don't even probably realize that how much of, what are even the possible concerns? Like the fact that there's so much human labor that goes into them, and wondering about like, wages and so on, and work conditions, to how much compute it takes and the strain on the environment. So just making people aware of that, I think, is a first step.
Question is, you won some competitions when you're young. Does that changes or influence things down the road?
I haven't won any piano competitions lately. I think so I've always been active in piano, and I still play a bit these days. And for a long time, it was always a parallel track, and it was nice because there was a sort of a hobby aspect of piano. There was a few years ago, I had 2 postdocs who I really wanted to figure out how to combine music and AI. So we had a number of papers on essentially training music foundation models, which was pretty cool, because then for the first time it got me to really kind of the 2 parts of my lives which are important kind of crossed.
Any other questions? Last one. Yes.
I guess any general advice about getting involved within the research?
Yeah. So general advice on getting involved in research at Stanford.
Yeah. So in terms of getting involved in research, there are definitely official channels. For example, there's a Curious program that people can apply to. And then there's unofficial, channels where, the nice thing about research is that everything is open. So you can see what research is happening, who's working on what. And one recommendation is to just engage with that. You look around at people's websites, you find a paper that you like, you read it, and then try to engage with either the professor or the student. Like you email Ken, and it's like, oh, I read your paper. This is so wonderful, and I have these other ideas, and you can try to try a more bottom up approach. The other thing is the final project in the class can sometimes be a way to try to do some research, which can continue into something bigger. There's no one size fits all solution here. Yeah.
All right. We're at time. Thank you so much, Percy. We can also read one more questions, but I think we're out of time.
Okay. Yeah, we should probably stop there.
Skip that. Yeah. Well, thank you so much for taking the time to answer all these questions.
Okay. Thanks, Ken, for moderating. Yeah. And thanks, everyone, for sticking with us through this class. It was a pleasure teaching. And, also thanks to the teaching team here for helping out. Hope you enjoy the class, and enjoy the rest of good luck with the rest of the quarter. Yeah.